Who are you? What's your role? And where do you work?
I'm Josh Seifer. I work at Sonos as a senior DevOps engineer.
Now, you mentioned in terms of Kubernetes tools that you're into, Carpenter is one of them. Why is that? Why should people be paying attention to Carpenter?
I feel like Carpenter's really just changed the game with how autoscaling works. Like by using workload-based constraints to actually schedule things, it's like led to like way more efficiency. Like we're talking like 30, 40, 50% better efficiency in like how we bin pack and how we schedule and bring on resources. So it's just been a real game changer. And the APIs for Carpenter are really extensible. Like I really like that like you can essentially train an AI model and feed that into the Carpenter API and then suddenly start to do predictive analysis on scheduling in nodes and for either seasonality or things like that. It's just really cool.
In terms of looking at the landscape and other options, alternatives that might not be there for Carpenter, what are the ones that you most commonly come in contact with, and what differentiates Carpenter from those other options?
One thing that I do like about Carpenter is now it's in the open source world. Like a lot of the different cloud providers all had their own implementation. I don't know, everything just got very niche and very specific to a platform. And so now Carpenter's platform agnostic. Of course, it works really well with AWS. I'm very heavily invested in AWS, but I'm just very excited that we can start to standardize that across all the different cloud providers.
In terms of that need for standardization, Kubernetes turned 10 years old this year. What do you think we can expect in the next 10 years to come? More standardization, more introduction of AI technologies, what else?
I think we're going to see just a lot better efficiency. I think it's going to, sustainability I think is going to play a big part in the future. Like we've just been burning GPUs with AI and we're just like, let's just throw more GPUs at it. Let's burn more resources. And so like, if we can get more efficient about actually using our compute, I think it's like we're going to see a lot of that as time goes on. Like we're going to really start to care about sustainability and energy efficiency, which we haven't really done that much so far. It's just been kind of throwing spaghetti at the wall with provisioning.
For people that want to take their first step towards better sustainability, what's your recommendation?
My recommendation is to really look at the data of how your workloads run. A lot of clusters are completely over-provisioned, and I think you could start by just like doing something as simple as like load testing or performance testing your applications. Make sure your container requests are appropriate. Look at the data, put the work in to test it, and then create some realistic resource limits, resource quotas, and like start to build that based on real data. Like a lot of times it just feels like a guess, and I'm guilty of that too. But yeah, so that's really where I would start.
Kubernetes has many features. What's your least favorite feature or the feature that you would like to see improve the most?
I would love to see the vertical autoscaler get a little bit smarter. Right now it feels like you're painting with a really broad brush, and I have just a lot of like, it's hard for me to trust it and to hand over like scaling the resource requirements of like an individual container just to this magic VPA. Like it just doesn't quite feel right yet. And so I would love to see that become a little bit more intelligent, have better data that comes out of it, and have better knobs to tweak. And I just don't think it's quite there yet.
Since you mentioned over-provisioning, one of our guests wrote an article about over-provisioning. What strategies have you found effective in controlling over-provisioning in large Kubernetes clusters?
Well, so I talked about performance testing, and I think that's really like knowing your actual needs is super important. So that's a really great thing. Other than that, I think you really need to understand your priorities. Like, what are your most important workloads, and do you have them in the right priority classes? Do you have them in the right tiers in such a way? Because like once you understand like the real basis of like what you're doing, you can structure your clusters around that. A lot of times we're just like, we need a cluster with X amount of nodes so it's highly available. We need a lot of IO, or we need a lot of CPU, and like we don't spend a lot of time getting close to the work. We've a lot of times created these self-service platforms and just hand it over to the developers and say like, tell us what you need. And so like by really building out that tiered approach to priority and importance, I think it kind of gives you a better picture.